Hello, welcome to class. Let's discuss the concept of binary operation. To have a big picture view of binary operation, I will begin by explaining the term binary and then operation. Now, when you talk about binary, you're talking about two elements acting as units. Binary implies two elements acting as a unit. It talks about pair. Binary talks about pair at all time. It talks about pair at all time. While operation is a mathematical or logical process that derives one entity from the other. It derives one entity from the other. Let's talk about plus. Plus is an operation because when plus is interposed between two elements, it implies another element. Minus also is an operation. Division is also an operation. Multiplication is also an operation. Let's consider a set of natural numbers which is called counting numbers. We have 1, 2, 3, 4, 5, and I can make an omission. It goes further to infinity. Now, if plus is interposed between 1 and 5, the result becomes what? 6. You see that plus is now a logical process because it derives 6 from the other entity 1 and 5. Same thing as minus, same thing as division, same thing as multiplication. But then what is binary operation? I want to define binary operation to you now. What is binary operation? Binary operation is defined with respect to a set. So for us to define a binary operation, let's assume a set. So let A be a set. Let A be a set. Binary operation on a set A is an operation that drives pair of elements of A to an element in A. Let me put it in writing. An operation, let's call the operation, let's take it as a series. An operation is called a binary. It's called binary operation. Okay? An operation is said to be binary operation on A if this drives pair of, or let's say any pair of elements of A into A, any pair of elements in A to element in A. Let me explain things now. Let's assume let X and Y be an element of A. Now, we talk about pair. It talks about two things acting as a unit. Now, this operation is called a binary operation in A if it drives the pair. If it drives the pair of elements in A to an element Z, such that Z is an element of A. So if it drives for each pair, for every pair of elements in A to an element in A, then we say that this operation is called a binary operation in A. Let's take natural number as a constructive instance. Consider n the natural number. Consider the natural number. Let's call it n. We have 1, 2, 3, 4, 5, 6, 7. It goes to infinity. Now, you see that the plus as an operation is a binary operation in n. Let's see. For all pair of elements in n, when you interpose plus between the both elements, it gives elements in n. Let's have 3 plus 5 becomes 8, and 8 is an element of n. So we say that the pair now, this drives the pair to 8. Hence, when you talk about binary operation is an operation that drives element of a set to an element in a set. But let me give the precise definition of binary operation. Okay, let A be a set, an arbitrary set, and if this is an operation, this is said to be a binary operation on A. It's a binary operation on A if for all x, y, two elements acting as a unit, x and y, this drives it to z element of A, and it becomes for all. So we have this becomes the set of all pair in element of A. It drives to z such that z is an element of A. Now you see that when you talk about set of pair, when you look at this, we assume that x and y is an element of A, and we talk about the set here, so we can still write this to be this, such that this is a member of A, because we assume this is a member of A, and y is also a member of A, and it maps to z, such that z is an element of A. So what you have to say, you see that this is the set of pair, and this talks about the Cartesian product between A, and it moves to elements in A. So we say that this will come now to be, this becomes from the set of Cartesian product of A times A, it terminates to A. Hence, any operation that satisfies this is called a binary operation on A. I guess I will end here. Just flow with us.